So we've taken the last several days to build these VAWTs, these vertical axis wind turbines, the Savonius and the modified Darrieus. Hi there and welcome to Carpenter Resources. In this video we are going to be looking at the construction of a modified Darrieus from the use of wood and steel. So you can see here where we are cutting sections for the airfoil itself for the modified Darrieus or gyromill or H-rotor as you may choose to call it. So we selected the length of 1 foot, which is 300 millimeters, because this is a 1 to 10 section. We are designing a 100 watt vertical axis wind turbine, which is a modified Darrieus, and when you reduce it by a scale of 10, it comes up to 1 foot, which is why we are cutting 1 foot for each of the airfoils and the blades of the Darrieus. So from there we then went on to fabricate the rotor and the stator using screws. We use some bolts as the stator and the support for the VAWT. So you can see here they have been separated. For on the left you have several screws with the stator. It also is meant for the modified Darrieus, and on the right is meant for the Savonius. So here they are welding the base for the VAWT itself. Although the plan was to have a heavier base, but it had made it difficult for carrying and mobility. So we built a base that is much lighter. So sometimes you will see that the architectural model of this VAWT tips over because of wind in the environment. So if the wind is excessive, it tips it over. And another thing is that the rotor part of this miniature model doesn't rotate because of excessive friction. So you can see how hard it is when I turn it by hand. So there's excessive friction that prevents the rotor itself from rotating the blades when there is heavy wind. Rather, the wind turbine itself is going to fall to the ground. So you see here the rotor has been welded. These long steel rods are the rotor parts of this miniature wind turbine. So due to the heat, it was not fully rotating initially, but later on it began to rotate. So these long steel rods are the rotors for the two different wind turbine types. So here the spokes, the 3 spokes for the modified Darrieus has been welded in place, and we now have it with the different nuts and washers have been installed on it. So this is ready for the installation of the airfoils themselves. The blades are ready for installation, having welded the spokes, the 3 spokes for the blades themselves, which is on the rotor itself. So we're here at the workshop, the wood workshop. Here are some tools that were used to produce these blades, because it was difficult. On a good day you could use CNC, you could use 3D printing, but we used wood and different hand tools. It was carved by hand. So you have the screw sheave, you have the sharpening stone, you have the tape, you have the planer. We also use, there's a planer there in the background, we use the planer as well, and the chisel in order to get the work done. So this is here the frame of the VAWT itself, and making final surface finishing of the blades prior to spray painting. So there are some fillers placed on the blade themselves, and is sandpapering them at the time to get a smooth finish. So each of the sections, altogether there are about 6, because we produced 2 of these models, one of which is being taken for an exhibition, and the second is what will stay back with us. So these are the cross sections. So initially we wanted to make 3 different airfoils but we ended up settling for just one, which is the E387F4. Initially wanted E387, FX63137 and S1223F4s, but because it was difficult to get the others by hand, we just settled for the E387F4, which is what you see here. So we took it for painting. Initially, first of all, we primed the surface using a kind of gray primer over the black paint, which is the frame of the vault, as well as on the wood. So we use a primer on it. Afterwards, after the primer was used, the first coat of the white paint was sprayed onto this vault. Subsequently, you had a second and a third coat was sprayed, and we finally got this out, which is the vault itself. So like I said earlier, the base is not that robust, so if there's heavy winds in the vicinity, it tips over. So that will be corrected after this exhibition. So we are going to modify it and increase the base size, but basically just because of the lack of materials at the time, because this was done as a matter of urgency. So subsequently, when there's more time, the base is going to be made more robust to prevent it from tipping over in high winds. Thank you for watching this video. This is Carpenter Resources, where we create for better living.